Hey, good afternoon, everybody. Welcome to another webinar here with UE Systems. I'm Maureen Gribble, and today we are going to be talking all things electrical safety and inspections with ultrasound. Super important topic, a really great application for ultrasound that not everybody is necessarily aware of. So thought it would be a good time to highlight this. And actually, I saw today on LinkedIn, I guess it's like Electrical Workers Safety Day. So it seems pretty relevant. Didn't know that until today, but happy coincidence, I suppose. So before I turn things over to Doug, who's going to be presenting, just a couple slides here. Just want to, as you're here learning about the electrical application, just kind of keep in mind some other opportunities that we have as far as training. We're continuing to offer our online level 1 and level 2 ultrasound certification classes. And we are also starting to put in some in-person classes. So we're finding that we've got some places where we can do that, and of course, safely and all those good things. So keep an eye on our uesystems.com website for the schedule of classes, but just know that those are offered throughout the year. And we also have all of our application-specific online training classes. So we have one on leak detection, steam traps, bearings and lubrication, and of course on electrical inspections. And so those are kind of more, maybe if you sat down and took a class all in one sitting, it might take you about 3 hours or so. But the cool thing is they are self-paced, so you can kind of take them at your leisure from, anywhere, anytime. So keep that in mind. And if you want to learn more specifically about electrical inspections, then maybe checking out that online course would be something to do. And then I'll just kind of throw a plug in here. We're really excited. Some of you probably have been following kind of this leading reliability journey that we've been on for over a year now. We kind of started the initiative with our friends at Fluke Reliability, Iridicio, and RDI Technologies last March when the world shut down, and we provided lots of, almost weekly webinars, all different kinds of topics. And then we held our first Leading Reliability virtual conference last July. It was, certainly different, but at the time, everything was different, but it was really successful. And so we continued on with our webinar series, and we held a second virtual conference in January. And we're happy to announce, some of you have probably seen it already, that in August, we're actually going to do an in-person Leading Reliability Conference in Clearwater Beach, Florida. So for those of you that had attended our Ultrasound World Conferences in the past, we're going to be at that same location. So it's a great spot. And we just think by the end of August, we should for sure be able to have a great conference and be together again and learning in person and networking, of course, in person and get out from behind these computer screens. So if that's something that is of interest, it's leadingreliability.com is the website, and we're really looking forward to it. And hopefully we'll be back with, or we will be back, with an Ultrasound World Conference next May, same place. So just wanted to kind of get those in your brains before we start talking electrical inspections and safety. A couple more notes on some housekeeping things. So we are going to, we are recording this session. So if you have to hop off early, or if you've got colleagues that needed to hear this and couldn't, we'll make this available online. So you can always email me if you want a link to it, or you can always check out our YouTube channel, and that's where all of our recordings are. We definitely welcome questions, so you can type those into the little chat box, or rather the questions box, and I'll be keeping an eye on those, and we'll get those tossed over to Doug as necessary. And then, of course, at the end, we'll have some time. And we are going to have some poll questions throughout, so we're going to try and keep this, interactive as best we can when we're all, separated, but try and make it fun today. So, and last thing, I'll just point out, we are doing this live, and, so just bear with us if we hit any audio or internet connection hurdles. We'll jump on fixing those just as quick as we can. But it is nice to at least feel like we're all together here for the next hour. So with that, I am going to change the screen over to Doug, and Doug will let you take it away.
Thanks, Maureen. Welcome, everybody. Very excited this afternoon to have a chance to talk about one of my favorite applications for ultrasonic technology, which is electrical safety and inspection with ultrasound. I've had the good fortune to be around UE systems and ultrasound for the past 30 years, and it's been awesome to just see how the acceptance level for this technology as a integrated tool of the toolbox for electrical inspection has become. Um, just getting my screen set up here from the beginning. How's that look, Maureen?
Perfect.
All right, excellent. So, yeah, it's really exciting to me. It's taken on a lot of momentum over the past, say, 15 years. It's really become an integral part of everybody's inspection program. So, we're going to spend the next about 45 minutes talking about several different topics inside of electrical safety and inspection with ultrasound. Really welcome your questions, welcome your comments. As Maureen said, you've got the ability to type them in, and we're going to do some poll questions just so I can sort of get to know what the audience is like as well. Just a little bit about UE Systems. Founded in 1973, so we've been around forever. Our headquarters and our manufacturing is up in Elmsford, New York, about 20 miles north of New York City. Um, we offer both handheld and continuous monitoring solutions. Now, what's really taken off over the last couple of years have been our continuous monitoring solutions, and I'll make a brief mention of them here, and I'll also talk a little bit later in the presentation about some continuous electrical monitoring solutions that UE has developed over the last couple of years that I think you'll be very interested to take a look at. Um, we're big believers in training. We feel that to get the very best out of your investment in a technology, um, you know, the vendor, the manufacturer needs to be able to offer um, multiple different tiers of training. We believe in offering the very best in support that we possibly can. And to that end, we've put a lot of time and effort into our training offerings, both pre-COVID and actually during COVID. I'll give a shout out to our training department for putting together a great online offering for the level 1 and level 2 for those folks who couldn't attend. And really for a while nobody could attend any in-person trainings, so a shout out to those guys. A couple that I'll just point out though from a training standpoint: one is our Smart Start program. It basically lets us set up monthly meetings with customers to go through helping them put together their program from a software standpoint. It's something we've done informally for many, many years, and now we've got a formal program in place. So if you're using ultrasound, regardless of the application, and you want to use the software for analysis, for record keeping, for trending, for reporting, talk to us about our Smart Start program. It's something that we're really excited about. And of course, Maureen mentioned level 1, level 2 ultrasound trainings. We've got the online version for those that can't go and do it in person, and we're starting to, as things open up, offer the in-person trainings available both as what we call an open enrollment, but also if you've got a group of folks just for your company that you want to get trained, we can do that online or in person. And lastly, some what we call implementation programs, much more of a hands-on, much more tailored to your individual needs at your individual plant. We offer that in a 2.5-day and a 4-day, same basic idea, just based on the size of the plant and the number of people that you're going to have. So we've got, I think, training very well covered. Ask us about it. We're happy to spend some time, tailoring a course to meet your guys' needs. So how about you guys? Another first poll question here. Who out there in our audience today is actually a user of ultrasound in your facility?
All right. And I'm going to launch this poll. And it's just a simple yes or no. And we'll see what kind of responses we get here, Doug. Mm.
Awesome. We'll see if we can
Wow, we've
beat
got,
the last webinar.
yeah, I know we're almost at full participation. We got 76% yes, 23% no. So the yays have it. So we'll close
That's
that out.
absolutely awesome. Hopefully we'll have 23% converts after we get done today.
Exactly.
Um,
We'll be busy. Give us a
that's
call.
right. Right. Um, so application wise, if I start at the bottom, obviously today, based on the name of the webinar, we're going to spend most of our time, we're going to focus on electrical safety and inspection. But for those ultrasound users out there, ultrasound is one of the most flexible technologies out there from all the condition monitoring technologies. We can do compressed air, gas leak detection, um, really big on the mechanical and rotating equipment side of things, especially with our digital reliability instruments. And what's been super exciting over the last couple of years is to see condition-based lubrication really just take off. We've got our grease caddies, but then we've also developed a new product, which many of you have seen some webinars on. If you look at our website, it's basically 24/7 continuous monitoring of your rotating assets. And we've taken it even a step further than just identifying when they enter some type of a failure mode. We'll catch it even earlier on the P to F curve. I like to say we sort of live to the left of P. And before the failure even has a chance to manifest itself, we're picking up very subtle increases in friction. And from any place at any time, we're able to lubricate that asset using single point lubricators as part of this integrated system called the OnTrack Smart Loop. So we're super excited about that. Anybody who's into lubrication, please ask us about it. We love putting on personal presentations for this, and it's just something that's nothing like it out there in the world. Um, we do steam trap inspection, of course, with ultrasound technology. That's been a great application for years. And then, of course, today we're going to talk about electrical safety and inspection. So I'm going to go ahead and get to that. One more poll question before I get into some nitty gritty here. What applications does everybody use ultrasound for out there? Of our 77%, what applications do you guys use it for?
And you can select more than one. So it's multiple answer poll here. All
I
right,
didn't
leak
want to be the only
detection.
person clicking buttons today.
Yeah. Leak detection and bearings are kind of taking an early lead here, with about 46% on doing that are using it for electrical. But we've got we're a little low in steam trap inspections, so maybe that's a good webinar here in the coming months to hit steam trap. We got to bring those numbers up a little bit. But yeah, nice little mix, Doug, of leak detection, electrical bearings, lubrication. We got some work to do on steam coming soon.
Fantastic. Fantastic. Okay, so let's get right into it. Electrical safety and inspection using ultrasound technology. Today's discussion, we're going to talk a little bit about why. Why ultrasound? Why do we do electrical inspection on our energized assets? What's the purpose of it? Why has it become so important that we be monitoring our switch gear, our transformers, and all of our energized electrical gear? We're going to talk about how to do it, and we're going to talk about how it works for a little while. And then lastly, we're going to talk about, what can you do? What are, what kind of reporting, what kind of analysis, and what do you actually accomplish by doing the inspections? What kind of fines are available? And I've got a couple of examples at the end of the presentation that we'll talk about. So the why, the how, and the what. A little bit about the why. Really, electrical inspection with this technology has been driven by four different things. First and foremost is safety, and we'll talk a little bit about that. The next, believe it or not, is insurance companies. The industrial insurance companies out there have driven a lot of the condition monitoring inspections that are being done on electrical, but also on some of your other assets. And I'll talk to that a little bit. There are some recognized standards out there, NFPA 70E, NFPA 70B. So there's some standards that are driving companies to do electrical inspection using different technologies, especially ultrasound. And then lastly, the what's in it for you is equipment reliability. We're all looking to, decrease any downtime. We're looking to, find problems before they manifest themselves in catastrophes. And technology is a great way to do that, especially ultrasound technology on your electrical and energized assets. So one thing we're big believers in is only relying on one technology certainly will increase the risk of you missing something. So for those of you who have an infrared inspector coming in once a year, once a quarter, um, think about adding ultrasound to that. For those who are just relying on ultrasound, think about adding infrared and other inspection, visual inspections. Um, there's all types of technology available today, and it keeps changing, and more is available. Um, Partial discharge testing. There's all these different new technologies out there that are great for finding out if you've got problems with your assets. So we're big believers in the multi-tool toolbox. So a little bit about safety. Um, there's probably similar information and similar stats to this all over the place, but I pulled these out, which was a report published in Industrial Safety and Hygiene News. On average, there's about 30,000 arc flash incidents every year. Of those 37 arc flash incidents, 7,000 burn injuries, 2,000 of those end up in the hospital. And the real horror here is there's about 400 deaths a year from arc flash. Can it always be prevented? Probably not. But I would venture a bet that a lot of these arc flash incidents could be avoided. And we'll talk a little bit about that. So what's an arc flash? Really, it's a sudden release of electrical energy through the air. And the problem and the reason it causes injury, hospitalization, and death is it creates a plasma fireball with super high temperatures. We're talking like 35,000 degrees F. Surface of the sun is only 9,000. So we're talking unbelievably high temperatures. We're also talking an explosion. So that rapid heating, causes a lot of extreme pressures, and that results in an arc flash or an arc blast. All right, that can vaporize any of the components of the switchgear. The copper conductors expand up to 67,000 times the original volume. That arc flash produces fire, intense light, pressure waves, and flying shrapnel. So even if you're completely outfitted with the proper PPE, if you're exposed to an arc flash, if the burn doesn't get you, perhaps the shrapnel does. If the shrapnel doesn't get you, perhaps getting thrown across the room by the extreme pressure will. So we don't want to be involved in an arc flash. And if there's anything we can do using technology to, mitigate the possibility of being involved in an arc flash, we want to try to do that. So it can be caused by a lot of different things. One of the big ones that we hear in talking to, companies that have had an arc flash incident is opening a door or a panel, specifically on switchgear, if there's any kind of a problem going on inside. So one of the ways we mitigate that with ultrasound is before that panel is ever opened to do an infrared inspection, a quick ultrasound scan around the air gaps of the door can actually tell you if you've got any popping or crackling noises internally that would tell you, don't open that panel or don't open that door. To randomly open a door, whether it's for visual inspection, whether it's for infrared inspection, is crazy and can definitely be a source of an arc flash. Other things that can cause it, of course, dust, people working inside of a cabinet, dropping a tool, accidentally touching something, the material failure, corrosion, you know, bad installation in the first place. All those things can happen, but one of the largest causes of it really is, just opening that panel or that door without any kind of a pre-inspection. So there's really three different things that are going to determine how bad that arc flash injury is. One is how close you are to the actual arc flash, and are you wearing the proper PPE. So I would say, for all those who are required to work around electrical assets, don't skimp. No matter how short a period of time you're going to be exposed to those assets, it's a good idea to be, fully decked out in the proper PPE. Um, that can help you from a burn standpoint. It can't always help you from, getting thrown against a wall from the actual explosion, but at least it can help you from the burn standpoint. The other thing is the temperature, and the last is the time for the circuit to break and for the arc flash to be over. So how long does it actually last? Safety's everything. So, and you hear people out there in a plant who are really comfortable around electricity, but they're not electricians, or they're not properly trained in how to handle electrical apparatus. So no matter how comfortable you are, no matter how many ceiling fans you've put in at home, no matter how many times you've wired new outlets in the basement, my advice would be, from what I've heard in facilities and from safety managers, is treat every single encounter, every time you're around an energized asset, treat it like it's the first time. Use the checklists, follow all the safety procedures, do not cut corners, because we certainly don't want to hear of any of our customers out there that are involved in any kind of an arc flash or any kind of a dangerous problem that has to do with electrical assets. Don't be these guys. Threw a little levity in there, but funny enough, if you look on the internet, you can find hundreds of pictures like this of real people doing dumb things. So we will say, with especially electrical inspection, with any application, when it comes to condition monitoring and plant reliability, any of your inspections, safety should be a top priority, but especially when it comes to working around electricity. The downside is just so bad. A little bit about insurance. This is pulled directly from a major industrial insurance provider's website. Some of the things that they do for their customers, for their risk prevention and control. They're out there using technology. They're doing reliability assessments. They're doing infrared, oil, vibration, and ultrasound. So it's something that you probably, if you currently have an ultrasound program for your electrical assets, if you're thinking of starting one, talk to your insurance provider. I've heard many insurance providers will actually give a discount on premiums, based on the type of inspections you're doing. Some of the providers will come out and do inspections. Typically, they're more of a cursory inspection. And really, always remember one thing: as much as we love our insurance providers, they don't really have your best interest in mind. They have their own best interest in mind. They want to make sure that they're not going to have to pay a claim based on something that could have been prevented. So if you work hand in hand with them, you can certainly, shift that, whose best interest is it to do these inspections, into a little more on both sides and make it a little more even. And I've heard a lot of insurance providers, work with their clients on setting and helping them get reductions in premiums based on the types of condition monitoring they're doing. Standards. Um, if you're doing electrical inspection and you haven't had a chance to look through this standard, I would strongly recommend someone in your maintenance department, in your shop, gets this standard and has a chance to review it. It really helps you put together your electrical preventive maintenance program. Has ultrasound mentioned in a couple of sections, but it talks about all the different technologies. So it's really a great reference, NFPA 70B. I would also recommend getting a hold of NFPA 70E because that also outlines a lot on the safety side. So these standards are available. You can look them up on the internet, you can buy them and get a copy of these standards. I wouldn't be out, if I worked in a plant, I would not be out in the plant doing electrical inspections without reviewing these standards first. Lastly, equipment reliability, another driver for doing electrical inspections. I'd ask you to take a second and ask yourself some of these questions. How important is the electrical distribution system in your facility? I would put it to you that it's critical, critical, critical. Without electricity, most of your processes, are just not going to work. Your plant's not going to operate. Look at the consequences if you have an electrical failure. The safety obviously is paramount. That's number one. But then take it a step further. If you've got electrical failures, how does that affect your downtime? Interrupted production. Those damaged assets from an electrical failure are costly. So in addition just to the downtime and production costs, look at the cost if something is burned up. If you've got switchgear that due to an arc flash incident, it blows up, you have to replace the switchgear, but what about the other assets that are in close proximity to it? What kind of peripheral damage is going to be caused by an electrical failure? So it is one of the huge, huge, huge areas of a cost basis when there is a problem. Look at the criticality and work yourself through some criticality exercises of your electrical assets. There's plenty of ways to do that. There's plenty of consultants out there that'll help you with that. There's tools you can get. You could look at SMRP's website, the Society for Maintenance and Reliability Professionals, and there's some criticality assessment tools that are available there. But look at the criticality of your electrical assets. It'll help prioritize which ones you do inspections on and how much time you spent doing those inspections. Look at history. You look at any electrical assets that have failed or that they even could fail, and look at how they have failed. That's the most important thing, so you're not repeating history. So certainly look back, talk to people in the maintenance department, look back at any reports you can get a hold of and see which assets failed and how they failed, see how you could have prevented them. And lastly, do you have a failure mode based strategy? And what I mean by that is look at the different assets, look at how they potentially could fail, and then do you have a technology that matches up with that failure mode? So when we look at ultrasound, any ionization-based failure mode, and we'll talk about that a little later, is something that you should be addressing with ultrasound. Any resistance-based failure mode is something that really is better addressed with infrared. So not every technology is going to be able to identify every failure mode. So when you're putting your program together or when you're adjusting, to make your program better, look at a failure mode based strategy based on your knowledge of those assets and how they could potentially fail. Just a quick example on equipment reliability. This was at a gigantic food manufacturer that everybody's heard of. During a normal ultrasound inspection, a once a month ultrasound inspection where they walk by and scan the cabinets, they heard cracking and popping sounds. Just a normal routine inspection. They then obviously got the proper PPE. They, shut the equipment down, opened it up. They looked at it visually, couldn't find anything. They did a follow-up thermographic inspection, and they did identify some high heat on 2 out of the 3 phases. So based on all of that, based on the thermographic inspection and the ultrasonic inspection, they scheduled some downtime to replace the breaker, and while they were doing that, they found out they had some bolts that were holding the buswork together that weren't properly torqued. So all kinds of problems identified through just hearing some cracking and popping. Continued operation. If they hadn't done that work, there's no doubt that would have been a plant-wide downtime event. So just from a reliability standpoint, electrical inspection is extremely important to do. So let's talk a little bit about the how. Unless, Maureen, you've got some questions that have filtered in that you think I should address now?
Nope. So far, we're good.
Okay, so we'll address them at the end. So let's look at the how. How do we go about doing it? It's pretty easy, you know, from a from a listening standpoint, which is the traditional, thought process with ultrasound. Hey, let's go listen to the asset, see what we hear. So again, scan it, listen to it, listen for popping, crackling noises, any kind of anomaly that doesn't sound quite right. Um, Note any deviations, and then extremely important, record the sounds. It's from an electrical application standpoint with ultrasound, it's probably the most critical application for sound recording because it lets you analyze it at the end of it. And we'll talk about that in just a few minutes, but we're able to actually get a pretty good feel for and a gauge on severity, but only when we've got the ability to look at those time waveforms and to be able to look at those sound recordings. It's very difficult with just your ears to determine severity of an asset. So what kind of tools? Any ultrasound detector is going to let you listen. So if that's the goal, you just want to go listen to cabinets before you open them up to do infrared inspections, fine. Any detector, any ultrasound detector will do. But determining what kind of a problem you have, is it corona, is it tracking, is it arcing, and determining how severe that problem is, you have to do sound recordings. Okay, so the 2 instruments we have for doing sound recordings is an UltraProbe 10,000 and a 15,000. The only real difference from a sound recording standpoint is you're able to look at the sound recordings and the time waveforms and spectrums right on the screen with a 15. The 10, you got to record it and go take a look at it on your computer. But extremely important if you're going to analyze and gauge severity that you have sound recording. The how, again, electrical inspection, any kind of voltage, doesn't really matter, but we're going to use the handheld devices in it similar to what we would do when we were looking for a leak. So for those of you who have done leak detection as an application, we're scanning, we're looking for the loudest sound, and then once we've found the loudest sound, we're trying to do a sound recording to determine what the problem is. We can scan around those cabinets any opening, any air gap. We don't have to open any energized electrical cabinets. So from a safety standpoint, that's huge. So what do we listen for? I mentioned we're going to listen for anomalies. Typically, the 3 types of things we listen for: corona, tracking, and arcing. We can also listen for loose or vibrating components. And when I say subject test equipment and interpret the meaning, you can't really determine what those sounds are until you understand the components of that particular asset. So if you hear vibration on a transformer, that's very normal to hear the windings vibrate on a transformer. But if you hear a tremendous amount of rattling and vibration in enclosed switchgear, that's not normal. So that could mean a severe issue. So again, do a little research, study the assets that you're going to go inspect before you actually go listen to them, so you know what to expect you're going to hear. So what's corona? If we're listening for corona, typically we get a lot of corona on insulators outside in a substation. We don't get a ton of, we don't usually hear a lot of corona internally in switchgear. Most of what we hear in switchgear is going to be a little more escalated than that tracking. But if you have a substation at your facility, it's a good idea. Ultrasound gives you the advantage of being able to stand outside the fence and scan from a pretty good distance and listen for things like corona. It's not always damaging right away, but it certainly can lead to other more severe problems. So by definition, it's just ionization. Um, of a connection or an insulator that at greater than 1,000 volts. But the byproduct of that ionization of the air is nitric acid, which is going to start to break down the insulating materials and break down the insulator itself. So it's not going to produce a whole lot of heat. In many cases, you don't pick up corona using infrared. So it is a failure mode that's best addressed with ultrasound. And what we typically would expect to see on a time waveform or on a spectrum is we'll see 60 cycle harmonics, but we'll see a lot of frequency content in between. And on the time waveform, we'll also see pretty evenly spaced discharges and pretty even height of the discharges. And a steady state, sort of a buzzing sound is what we'll expect with corona. With tracking, tracking has taken it a little step further. It's not just ionization that's dissipating into the air. It's actually found a low current pathway to ground. So we're going to get a little more damage. It's going to be a little different sound pattern. We may get a couple of harmonics on the FFT spectrum, but we're going to just mostly get a lot of frequency content. What's really telling is the time waveform. On the time waveform, we're going to see uneven heights of the discharges. We're going to see uneven time spacing of the discharges, and some of them will last longer than others. Arcing, the most dangerous of the anomalies we'll hear with ultrasound, that's a high current pathway to ground. You're going to hear a lot of bursts of energy, popping, cracking, very, very distinctive starts and stops of this discharge. That's a very, very dangerous situation. When we look at arcing, you can almost hear what you're seeing here. It's big bursts of energy, uneven heights, and when they occur, they're lasting a long time. They're actually, finding a pathway to ground. So very, very dangerous. Sometimes a vibrating component, whether it be a fuse clip, whether it be a nameplate, can fool you. One of the ways to determine whether it is a mechanical vibration or whether it's corona, because they do sound very similar, is by looking at the FFT spectrum and looking for where the harmonics are. In many cases, you'll see either a 60 cycle or a 30 cycle harmonic here in this spectrum, but you won't see a whole lot of frequency content in between like you did in corona. So the three things, everybody wants to know, how bad is bad? How do we gauge severity when we do hear something? And really, there's three things that help us gauge severity. One is, how much deviation is there in the amplitude? Is the sound constantly getting louder and softer? That's one thing that'll tell us it's getting worse. How often do we hear those pops or cracks? The more often we hear them, the more severe that failure mode is. And when we hear those pops or cracks, when that discharge occurs, how long does it last? The longer it lasts, You could be in severe tracking, or you could already be in an arcing situation. So really look at those three things: amplitude deviation, the times of the discharges, how often are they occurring, and when they occur, how long do they last? You can see a good example here. This is very severe tracking. You can see the uneven band height. You can see some of these discharges are very loud, some are very soft from an amplitude standpoint. You can see uneven spacing. You see some of these discharges are further apart than the others, and some are very close together, like in there. And then we've also got a high degree of frequency content. So on some of these, they're lasting longer. Some of these discharges are fat, some are very, very narrow or thin. So this is telling us that we have extremely damaged component. We've got a lot of tracking here, borderline of arcing. So this is a very severe condition that we're showing here. Another little poll here real quick. I'm going to very briefly talk about some permanent monitoring options for electrical inspection. So Maureen, let's see who out there has thought anything about permanent monitoring, and does it fit into their plans on at least their critical assets?
All right, so we just launched that. So kind of yes, no, and maybe you're in the process of it. So let's see what the survey says. Ooh, all right, so we're at about 70% have voted. We're looking at 45% saying no, 19% at a yes, and 36% not yet, but researching. So interesting.
Okay, excellent. So at least everybody's a little curious. This is a relatively new product that we have out. It's not really new technology. It's employing um, the existing sensors that many of you may be familiar with, the airborne remote access sensors. But in this case, we can mount those sensors on a cabinet internally, and this will monitor 24/7. You can take back the cables into this Foresight box, relatively small, 4 inches by 2 inches by 5 inches about, mount it near the switchgear, and you could send that information to the DMS software via either an Ethernet connection or a Wi-Fi connection, and then it just sits there and listens. When you've got an increase in amplitude above where you've set as an alarm point, it's going to immediately record a sound file and immediately record the dB. It's going to send a text or an email alerting you that there's a problem in that particular cabinet, and it's going to let you analyze that sound file from wherever you are, whether that be your laptop, your office, your home, and let you have the ability to take a look at severity. Is that something that you can wait, or is it's something that's an emergency situation? So that's sort of where a lot of the technology is going, both for electrical continuous monitoring, where you see here we've also got lubrication condition monitoring, we've got bearing condition monitoring. A lot of it is going to this remote sensing, and we did find out there was a lot of interest in that over obviously the past year, when there wasn't always the ability to go into facilities and run routes and do inspections. The interest was pushed to a much higher level to do this remotely due to COVID. So again, little repeat of what I mentioned earlier. Um, we're looking at uneven spacing of discharges, uneven band height, and heavy and frequency content. This is going to let us through those alarm notifications we get, and through the sound file that immediately gets recorded, we're able to tell severity from a remote location. We can do the same multimedia reporting, regardless of whether you use handheld ultrasonic tools or whether you're using the remote condition monitoring tools. Um, we have the ability to import, both the pictures of the wave files, whether it's a spectrum or a time waveform. We can bring in a digital photograph, very important for documentation. We've actually worked with some insurance companies that love this because you can document that you're doing the inspection because those photographs are time stamped and date stamped. And you can attach a recording that's time stamped and date stamped right to it. So that switchgear is in good working condition when it was inspected. Bringing in things like infrared images. So it's truly a multimedia report. If this report's emailed, you attach the sound file, someone can visually see it, and they can also listen to it. Another example, in this case, this was on a transformer. This was the time waveform that was heard. You could see that the severity here was a lot of frequency content, a lot of deviation in the amplitude, a lot of popping and cracking. Later on, was fortunate enough to talk to this customer, and once they were on a scheduled outage, this was a utility. When they were on a scheduled outage, that's what it looked like when they did a visual inspection. So they were able to determine that they had a severe problem with ultrasound, and then during the outage, they confirmed it. And I mentioned this earlier, where you can have corona or tracking problems. Here's an example of an insulator in a substation. This happens to be in Thailand. As you can see here, it's a little more than just corona. It's the beginning of tracking. And if you think about it, this is actually a brand new facility, but it had been so long since they actually installed these till when they were actually going to do the startup of this particular power plant, that the moisture in the air, the salt air, everything got to the insulators and coated them. So when they did fire it up, a lot of them already had issues. Now they could address these issues because they weren't that severe, but a lot of them just through a simple scan, in this case, 15 feet away, we're able to pick up whether there's a problem or not. Another transformer example, up on a utility pole. This was a situation again at a beverage company that during a routine ultrasound inspection, they picked up some popping, crackling on a transformer, contacted the utility company. They wanted to shut it down, but they actually scheduled a shutdown. Fuse holders separated, caused all the tracking. They estimated that if they'd have let that go and that transformer had blown up, it would have been a 2-day downtime event. So again, from a reliability standpoint, it pays to do these very simple, easy, safe inspections from a distance on assets that are outside your facility. So designing for success. I think many of you have service providers that come in. It's very common. I see in plants, service providers come in to do infrared inspections, and they'll also include ultrasound. Or if you do it internally, if you've decided to take that program on and you have the infrared cameras and you have the ultrasound devices, some things you want to think about. Follow safe best practices. Review NFPA 70E and FPA 70B, and follow safe best practices. Identify and look at the criticality of your electrical assets that you have in your plant. Obviously, you want to assign more tasks and more inspections to those supercritical assets. Use a failure mode based strategy. Look at what types of assets you have, how they can fail, and what technology is going to address that failure and be able to detect that failure early on. Refine your processes and procedures. Have written procedures that focus on safety, but they have to be easy to follow. And demand that either your inspection personnel internally or that your contractor follows those procedures to a T. That's the best way you can feel confident that they're going to do those inspections safely. Document everything, what you find with photos, with sound files, how many hours were spent, what kind of parts were needed to make those repairs. Review those results and share the success. That's the best way to keep a program, continuing on, a best way to keep that program going. So I never title a slide conclusion. I don't think that you're ever done. I think when it comes to improving electrical maintenance and reliability, you're never going to be done. So I never title it conclusion. Anyway, that's what I have, Maureen. Is there questions out there?
There are. So, in kind of looking through them and kind of grouping some of them so we can get through as many as we can, definitely some questions around kind of the software and how to best, you know, visualize what you're seeing, build those reports, et cetera. So maybe just talk to the software options we have, how we use those, maybe some training opportunities that we can share from that perspective.
Sure. We've got for those users out there, you're probably familiar with our DMS software, which is essentially our database software that lets you go out, store DB levels. But we've got what's called Spectralizer software that links directly to that DMS software. And what we're able to do then is build a route, put points into the DMS software, and then link an individual historic record over to a specific WAV file in the Spectralizer software. So once we've got that, and I'll actually jump back up here real quick. See if I have a good picture of it. This is what the Spectralizer software looks like. These are what the WAV files look like. What I didn't show here that you are able to do is use things like harmonic cursors to put a line basically on where the harmonics are showing up. So if they're showing up at 60 cycles, it makes it a little easier to look in between to see this frequency content. Was going to tell you you've got corona. Same thing if it is something like mechanical vibration. Again, you could put things like harmonic cursors on it. So it's pretty full-featured software that's included right with the instruments, or if you get or if you're choosing a remote monitoring option. In addition, showed this report. At the end, we call this a 4-pick report. There's multiple different reports that can easily be selected and built as you're with just pull down windows, that you can select a specific historical record in a tree, and that record is attached to a specific sound file. I hope that answers the question in a rambling way.
Yeah, and let me just address something else because a couple people have mentioned it, and maybe we should have been clear at the beginning. This GoToWebinar software is not great or reliable for playing sound files. The audio doesn't always come through, and we've banged our heads against the wall trying to make sure that works. But in the absence of reliably being able to play sound files as part of the presentation, and muddle up the middle of a presentation by trying to do so and having it not work, we have just opted to not do that. So of course, a lot of what Doug was sharing is very, of course, visually you could see the what arcing, tracking corona might look like visually, but hearing it obviously would have been nice. So we do have a sound recording library on our website, and if you want to be specifically kind of sent those sound file examples, we've got them in spades. So just shoot me an email we'll have our contact info up at the end, and we'll be happy to send those along, and even hop on, if you want to hop on a an individual Zoom meeting or something where we can play them, and walk you through them. We can do some of that. So apologies that wasn't something we could include, but we can definitely get you access to those sound files.
Yeah, for sure. The
So,
software is available even if you're not a user of our equipment. If you want to, or you're trying to decide whether you want to integrate ultrasound into your electrical reliability program, you can download the software from our website, and we're happy to get a trainer, as Maureen said, on a Zoom meeting, on a go-to meeting, whatever we can do to get on and actually give you some, an introduction to the software, an introduction to analyzing sound files, whatever it is that you want to take a look at. We're happy to
okay, perfect. And also, just so you know, if we don't get to everybody's question, we will for sure be following up with you guys individually offline. So don't worry. Maybe just one more, Doug, and then we'll wrap up and keep to our time here. But someone was asking about, they understood that a benefit to using ultrasound for inspections is that it works well on high voltage. But was wondering if that meant that ultrasound then wasn't great for low voltage. So maybe you can speak to kind of that, the voltage side of things.
Absolutely. It'll work on any voltage. What you have to think about from an ultrasound standpoint is when you get down into the lower voltages, when you do hear something, it's probably pretty severe. So with the higher voltages, you've almost got these levels, and you can look at those time waveforms, and you can say, well, there's a little bit of popping and crackling. It's starting to escalate. It's starting to get worse. The lower voltages to produce high frequency sound or produce ionization, you're not going to get corona below 1,000 volts. And the tracking issues that you get on low voltage are usually more severe from the get-go. So yes, you can absolutely use it on any voltage. I would say if you hear a lot of popping and crackling on very low voltage, you're already in a more severe type of a failure mode.
All right. So, okay. So that's great. Another common question: were we recording this? Yes, we were. We will be putting it up on our YouTube channel. So you can just go to YouTube and then search for UE Systems, and you can find all of our webinar recordings there. You can also email me if you want me to send you a direct link as well. So not to worry about that. And like I said, some of these are a little bit more specific questions. We'll follow up individually so we can be sure we totally understand the application you're asking about, and we can provide you with the best answer. So Doug, I'm going to take the screen back from you and just close out here. So again, thank you all for joining us today. Hopefully that was a great session for you to learn a little bit more about how you can be using ultrasound for electrical, and also some ideas for other ways that ultrasound can be used. So definitely let us know any questions you might have. I did want to again plug the Leading Reliability in-person conference for those of you that are using ultrasound and are using our DMS or our spectralizer software and want to get better at it. There's always room to improve. One of the things that we'll be doing as a pre-conference event is actually a one-day, actually a half day of software training. So that is included in the registration fee, which is only $595 for the whole conference. So if software training is something you've been trying to get, great excuse to get that approval to come down to the conference, and we'll get you spun up on DMS and spectralizer. So keep that in mind. And then I'm going to leave our contact info up here so you can get in touch with us with any and all questions, comments, concerns. We will take them all. And we will be coming back to you guys next month with some more webinar content, so keep your eyes open for that. In the meantime, stay connected with us on LinkedIn. And Doug, thanks again, and thanks everybody for being here. We'll let you all go. Have a great rest of your day, and we'll catch you guys later.
Thanks, everyone.